This is a video shot by a railway worker, recording the process of welding two rails by Thermite Welding. Next, let's take a look at how railway tracks are welded. This is a section of railway located in the mountains. Due to the impact of rock rolling, this section of track was severely damaged and needed to be replaced and maintained urgently. First, the workers used a track cutter to cut off the damaged track and then move the new track. The workers use crowbars to lift the new rails onto the wooden TIs, making sure the tracks are properly aligned. They then use a chisel to check if the gap between the two ends of the rails meets the required standards. Once the rails are in position, they clean the ballast under the track with homemade steel claws to make room for the welding mold. Next, the welding mold is installed. The red bricks the workers hold are graphite sand molds made from heat-resistant materials. It can withstand temperatures up to 3,500 degrees Celsius, which is crucial for the thermite welding process. Meanwhile, another worker prepares heat-resistant sealing mud on burlap bag. Once the mold is ready, workers carefully adjust the position of the rails with a measuring tape and hammer to ensure a precise fit. After aligning the tracks, the sand mold is placed between the rail ends and secured with a homemade locking tool. Then, the sealing mud is filled into the mold to prevent molten aluminum from leaking out during the welding. Once the mud is in place, a support is installed beneath the mold to ensure it is sealed tightly. After setting up the mold, workers bring over a heating device and connect the fuel pipe to the sand mold. They then ignite cardboard and use flamethrower to preheat the mold. This step is called mold preheating, which helps prevent the mold from cracking due to the extreme heat generated during welding. During the preheating phase, workers prepare the thermite welding compound. The welding agent consists of aluminum powder, iron oxide, and graphite. The prepared compound is poured into a high-temperature reaction furnace. Workers then lift the furnace to the welding site and place it over the preheated sand mold. The workers strike a match to ignite the welding compound in the furnace. As it ignites, the furnace releases white smoke and intense flames, beginning the welding process. In this process, aluminum powder reacts with iron oxide, creating a chemical reaction that produces temperatures over 300 degrees Celsius, melting the metal into liquid iron. This molten iron flows into the gap between the rails, welding them together. Graphite helps control the temperature and stabilize the reaction. Thermite welding also involves physical principles. Due to the difference in density between aluminum and iron, the heavier molten iron flows into the gap between the rails, while the lighter molten aluminum rises and flows out through channels in the mold to the outside of the tracks. As the fire went out, the welding process is nearly complete. The workers remove the furnace, dismantle the tools securing the mold, and clean off the hardened sealing mud around the area. While the weld is still red hot, they quickly bring in hydraulic equipment to push the two rail ends together, a process known as rail squeezing. This helps achieve a tight weld for the best thermite welding result. After the rail squeezing, workers use tools like axes and hammers to remove any excess material from the weld. Finally, they use a rail grinder to smooth the welded area, ensuring the two rails join seamlessly. And that's it, the entire rail welding repair is complete. If you like this type of video, please like, subscribe, and turn on the bell. See you in the next video.